In 1911, George Urban reported the discovery of the missing element below zirconium in the periodic table, but he was wrong, and the search continued. It was finally discovered by George Charles de Hevesy and Der Koster at the University of Copenhagen in 1923. It was found in a zirconium mineral, a Norwegian zircon, but it had proved very difficult to separate it from zirconium, and this explained why hafnium remained undiscovered for so long. Other zirconium minerals were now examined by Hevesy, and some were found to contain as much as 5% of hafnium. It meant the atomic weight of zirconium was wrong and a hafnium-free material had to be produced in order for this to be determined. The first pure sample of hafnium itself was made in 1925 by decomposing hafnium tetraiodide over a hot tungsten wire. But what is hafnium? Now we're going to go through some of general information about it. Hafnium is a lustrous silver-gray transition metal. It is named after the Latin word for Copenhagen, Hafnia. The element had some very important commercial application, including its use in the nuclear power industry, electronic equipment, which we're going to talk about more in detail later. Hafnium is extremely chemically similar to zirconium. In fact, separating the two elements is extremely difficult. Most commercial hafnium is in fact produced as a byproduct of zirconium refining. Hafnium is the 45th most abundant element on Earth, comprising about 3.3 parts per million on the Earth's crust by weight, according to Chemical. Hafnium is quite resistant to corrosion because of the formation of an oxide film on exposed surfaces. In fact, it is unaffected by water, air, and all acids except for hydrogen fluoride. But where can we find hafnium? Hafnium, as we said, is dispersed on the Earth's crust to the extent of 3 parts per million, and is invariably found in zirconium minerals up to a few percent compared with zirconium. For example, the mineral zircon and batalite, which is essentially pure zirconium dioxide, generally have hafnium content that varies from a few tenths of 1% to several percents. Alter zircons, like some alvites and satellites, which is a product of residual crystallization, show greater percentages of hafnium. Commercial sources of hafnium-bearing zirconium minerals are found in beach sands and river gravel in the United States, especially in Florida, Australia, Brazil, Western Africa, and India. Hafnium vapor has been identified in the sun's atmosphere as well. Now, last but not least, that we know a little bit about hafnium, let's look at some of its uses. Hafnium is combined with other elements to make compounds that can endure extreme temperatures. Fun fact, hafnium carbide, which is basically hafnium combined with carbon, has the highest melting point of any of the two elements, which is 3,890 degrees Celsius. Also, combining hafnium with nobium produces a compound that withstands extreme heat, so the compound is seen in rocket engines. Other compounds are used in kilns and furnaces as well. However, most of the hafnium produced goes to making rods for nuclear reactors called control rods. In a nuclear reactor, uranium is hit with a neutron. When this occurs, the uranium nucleus breaks up into the two nuclei, energy is released, and more neutrons are released. The released neutrons hit another uranium atom, and thus a chain reaction occurs. Hafnium is great at absorbing neutrons, and the hafnium control rods help control the number of neutrons released, preventing the chain reaction from getting out of hand and creating a nuclear bomb inside the reactor. And that would be very bad. So this is basically the main use. But then we have another surprising use in microprocessors. These are important parts of computers, tablets, cell phones, and other electronics. And as technology improves, these processors need to become smaller and more effective. And these are two things that seem challenging to accomplish.